Hey folks, so this is the second video for logarithms and their properties. I'd like to discuss with you a couple of special logarithms, and then I want to discuss with you three properties of logarithms. So first of all, the special logs that we have the common log. The common log always has a base of 10. And so you see here that I've written log base 10 of x. Now, here's the thing. When we write the common log, we actually never write that base 10. We simply just write it as log of x. And that is an automatic clue, as this is definitely a base of 10. If you can think of one thing that we deal with commonly, if I were to ask you what this symbol is, you could easily tell me that that's a square root symbol. And if I were to ask you, well, how do you know it's a square root and not a cube root? You would say, well, because there's no number there. A cube root would have a 3, but a square root has no number. And this is basically the same concept. If I write a logarithm that has no number base, it is automatically a base of 10. It's automatically a common logarithm. The second special logarithm that you're going to run into is the natural logarithm. And you'll notice here that I've written this log base e of x. We've run into that number e earlier in this chapter. And again, this is not the way to write the natural log. The way that we write the natural log is going to be ln of x. So anytime you see ln, your brain should think this is a log base e. So those are the two special logs, common logarithm and the natural logarithm. Then I'd like to look at three properties of logs. These are pretty common properties. The first one is the log base a. We don't know what that number is, but it could be anything. Log base a of 1. And the way that I really want you to think about this is turn your logarithm into an exponential. So literally, if I have a base of a raised to something equals the number 1, that's what I have written over the right. A raised to some power is equal to 1. Now, you've already had to memorize that rule back earlier in this chapter, and we know that anytime we raise a base to a power of 0, we're going to get 1 out. So log base a of 1 is equal to 0. One little way to just write this rule down is that any log of 1 is going to be 0. I don't care what the base is. It might be a base 10, it might be a base e, it might be a base 4, but any log of 1 is always going to equal 0. The second property that I'd like to look at is this log base a of a to the x power. So once again, let's turn this into an exponential. So a base of a raised to something is equal to a to the x power. And that's what I have written over the right. A to something is equal to a to the x power. Well, since the bases are already alike, I know that the missing place there for that question mark has to simply be an x. So log base a of a to the x is equal to x. Just a side note on this, just when you do this, these bases must be the same. That's the only way that this property is going to work for you. For property number 3, this is a raised to the log base a of x. Once again, notice that my bases are alike. And really on this one, you are mixing exponentials and logarithms up all in one problem. It's kind of like having the square root of 53 squared. We know that squares and square roots undo each other. And so the concept here is that I have an exponential base raised to a power, and my power is a log. So my exponentials and my logs need to undo each other. And so since they have the same base, it's like everything is undone, and the only thing that's going to be left over is the x, because the exponential and the logarithm undid each other.